To understand where to start, when you're trying to create a shader from scratch, it is actually helpful to look at how an image texture is treated in a shader. So let's take a look at this simple setup. I have an image texture up here, you might recognize this guy, and a material preview with a plane here. Now I just add an image texture node and select the image. As you can see, apart from a couple of options, the only input is this vector socket. But even if we don't plug anything into it, the texture is mapped onto the surface. The reason this works is that it's actually grabbing the UV map that is generated with the plane. If I just quickly add another UV map and change it a little bit, you can see that the UV map that is taken is just the one that is selected as active. And if I delete both, the texture does not get mapped at all, because the image texture node needs some coordinates to be able to map this texture onto the surface. So let's go back one step and take a look at how this mapping works. I just go to Input, UV Map, and if I plug it in here, as you can see, the result does not change. So let's look at the UV map itself. If you think back to how a vector is displayed, this translates into a two-dimensional map of x and y values that range from 0 to 1 on each axis accordingly. The red part of the color goes from 0 to 1 on the x-axis, and the green part on the y-axis. And if we look at how this is mapped now, we can see that the bottom left corner of the image is mapped in the position 0, 0, and the top right corner to the position 1, 1. And everything in between is mapped accordingly. So let's look more in detail at this coordinate map. Contrary to the image texture that shows a clear pixelation, the coordinate map is a continuous gradient without any steps. And no matter how far you zoom in, every surface point has its own coordinate values assigned to it. The pixelation happens only when we introduce the image texture. For every surface point, the image texture node looks up the color of the pixel that corresponds to the position. So you can think of an image texture as a lookup table, where the image texture node takes coordinates, decides which pixel belongs to that position, and then displays the according color. And the smudginess of the texture that you can see in the material preview is caused by the interpolation setting that is set to linear, as means to soften the pixelation effect. You can change this to closest to see the true pixels. The task of a procedural texture in Blender now is to replace this image texture node with a function that calculates the color on the spot rather than looking it up. The difference can be described as the difference between a lookup table and a mathematical function, where the coordinate values are used directly to calculate the texture, instead of looking up the color from the image texture. To be clear, the term procedural texture does not directly imply that it has to be this way. An image texture can also be created procedurally. And as a matter of fact, the image texture that I've been using here has also been created procedurally. As you can see, if I zoom in, I don't get the same pixelation anymore. The way this works is comparable to vector graphics opposed to pixel graphics. These high resolutions are not achieved with large file sizes, but by calculating it on the spot. The node graph in here that generates the image, which might look quite threatening as the first sight, holds all the information of how the shapes are drawn and not the shapes themselves. But if I zoom in really closely, you can see a different type of pixelation here. If you look closely, it is not connected to the same grid that you would get from an image texture, but it's rather curved. The reason this happens is the technique that I'm using to generate these shapes, and something I will go into later. But in theory, a procedural texture like this can have any level of detail. Let me just add in a Musgrave texture that generates a lot of noise, and if I zoom in, the detail just keeps coming. Another advantage of procedural textures like this is that they don't repeat over larger surface areas, like image textures do, which gives you tiling artifacts. The texture coordinates used to generate the texture don't need to be between 0 and 1, like they do for an image texture. If I just scale this Musgrave texture however I want, there is no repetition. That can be incredibly useful when shading larger areas or creating a shader that should be versatile for several situations. As a conclusion, the main takeaway here is that even for image textures, the bases are continuous coordinates, and a procedural texture fills the gap with an algorithm to be generated on the spot. So there has to be some type of input that the algorithm can use, and this is usually the texture coordinate space. But on top of coordinates, also other inputs can be used. For example, you can incorporate the object's geometry within the shader, but we'll go into this later.